Usually if I got to go a long way, I'll use a wheelchair. So what we're going to do when we get into lab 5, we went over the last 4. We went over labs 1 through 4, right? So what we're going to start doing is we're going to start drawing. I'm listening. You talking to me or somebody else? Oh, what'd you say? I thought we went over that. So lab 4 is not. This is still where I give you stuff. And then lab 5 is where we start designing. If you got, and I think I'm going to start adding this to the requirements for the course, that codified graph paper. So notice there's no curved lines. Everything is what? Everything is straight. Okay. So this is what I've added. This is the symbol for an e-stop. I actually put that on there. And then this is the symbol for a simplified symbol for a pressure service unit, right? Yeah. And I don't know what operator. I think this is the, if it's got that, it's a detent. So that would be the selector switch. So we come through the e-stop, it splits. Now, legally, and I think I told y'all, I'm using a program called Visio to draw these. And you're supposed to put a dot anywhere you have a connection. That's supposed to be there. Visio don't do that for us. I need to go back and do that. And they do have the symbol for the angled actuator. When I drew this last time I taught the class 5 years ago, I didn't know that. Ours has an angle actuator on it. So what we're going to do here is we're going to come up here and of course we'll right now it's going to come up here. It's set up to extend the cylinder the way it's drawn, right? It's going to extend this out. It's going to that's that roller plunger valve over there. I forgot. I can't remember. It's a 2. I think it's a 3 or 4 position. I mean 4-way. I can't remember. 2 position. And then that's going to cause our single acting cylinder to extend. But the single acting cylinder is doing it automatically, right? You don't understand that? Yes or no? I mean, all I'm doing. Sometimes we got to play around with this, guys, because to get that roller lined up so your cylinder hits. But if it hits on the top of the roller, it'll still actuate to right above the roller. And then we'll move it back. We're going to cause the double acting cylinder to retract as soon as it comes off the roller in our single acting cylinder. Is that right? Yeah. So any questions on this one? Pretty straightforward. Everybody okay? You okay, bud? Not easy. Can you go by your last name? I thought you did. You're not there yet. Now this is lab 5. You're going to design and build piston, but it's going to be parts that we already know. On a separate piece of paper, design and draw a pneumatic circuit that will extend and retract a single acting cylinder. You must be able to adjust the speed when the cylinder extends. Is that okay? And we're gonna, when in doubt, you're gonna do what? Meter out. So you're gonna put your flow control in the exhaust side, right? Now, if we put that flow control in the exhaust side, that means we should be able to control the time it extends, but when it retracts, it's going to bypass it. So it'll retract it. Include the service unit and e-stop button in your design. Everybody okay with that? So use that little simplified drawing. Everybody okay? I'm going to try to see if I can get one of these computers, at least one of these computers over here working, so y'all can come in, because I've got these books, and also I think on Blackboard I have all the symbols out of the Festo book. I'll make sure. Make a list of the components used in the design circuit, include the component's name and the Festo part numbers. Label the symbols on your circuit with the correct names and numbers using industry standard. Y'all understand the industry standard, right? So what's your actuator? 1A, right? Yeah, if we got one actuator, the first one on the left would be 1A. If we had two actuators on the same circuit, then it would be, those we call what? No, then we would go close. You'd go 1A1, and you'd go 1A2. Yeah, if you add a second actuator controlled by the same valve. Does that make sense? If you only have one actuator, then it'd be called 1A. Then the second circuit, which would be controlled by a different directional control valve, would be called 2A, right? Understand? Yes, no. Okay. Y'all need to bring up, I'm going to bring up the Amatrol prints. These guys are really, really good. And I think, so these are actually pneumatic diagrams drawn according to, I'm looking for pneumatic, here we go. So this has got a rotor actuator. So the first cylinder on the left is called 1A, the next one is called what? 2A, the next one is called 3A, the next one is called 4A. So we have four different circuits, right? You understand? Each one of them controls a complete circuit, right? Then we come up here, and you don't have to put, if this solenoids are named M, your valves are called what? 1, V, and then you put a number out there indicating the valve, number from bottom to top, left to right. Y'all understand that? Bottom to top, left to right. So notice this one is the first one from the bottom. It's labeled 1V1. This was the second one. It's the first one on the left. It's labeled what? 1V2. This guy over here is labeled what? 1V3. And these 1V, by the way, those are those magnetic sensors. Oh, we forgot to talk about this double rod cylinder right here. And here, this moves over to the second one. So this is the manifold. All these valves are mounted on the same manifold, which means they share the same exhaust, right, and they share the same pressure. This is circuit number 2. So this valve is called what? 2V1. The actuator is called what? 2A. That's what determines the numbering, is the actuator. So your actuator would say 2A. If we had another circuit, it would be called what? 3A. Y'all understand? Everybody okay? Then we start up, moving up. This is the next valve from the bottom to the left. 2V2, 2V3, right? You understand? This guy right here, this is just a gripper on a robot. This guy's called what? 3A. This valve is called what? 3V1. And there's no other valve. Let's see how these are, and we could bring up the Festo prints, and they would be exactly the same way. So this, notice there's no curved line. I see this all the time. People that do this kind of garbage, right? You know what I'm saying? So we need to draw pretty straight lines, as straight as you can. Draw your valves so I can see what the valves are. You need to line them up. I've seen guys, they'll just throw a valve up there and they don't line up the ports, which means nothing, right? Y'all understand that when you draw your thing. Everybody okay? If you're a crummy drawer, what do you need to do? Well, you need to go out and buy your pack of graph paper. If you do good, then it's fine. Everybody okay? Any questions? So you need to start drawing these according to the way you would run into them. You'd appreciate it if you got out there and saw these lines all over the place, and you're trying to figure out if they're connected or not connected. Now notice on industry standard, if we have a connection, we put a what? Put a dot. If you don't have a dot, you really don't have a connection. Everybody understand? Well, that's one thing I need to do. I need to go back and put dots, manually put dots in there. So everybody okay here? So just a single acting cylinder, flow control on the extender. Meter out, right? Everybody okay on there? Yes or no? Let's see what y'all got to do on lab 6 and then. Design and draw a pneumatic circuit that will extend and retract a double acting cylinder. As one cylinder extends, the other will retract. So we're going to use 2 double acting cylinders, and you're just going to pipe them opposite of each other. So when one extends, the other one's going to do what? Retract. Same piping, same valve, 1 valve, 2 cylinders. So one of them's going to be called 1A1, one of them's going to be called 1A2. It's still circuit 1, so what's on the left is the circuit number. Then A, and then the actuator number. So if you don't have 2 actuators, then you can use 1A, right? You understand? If you have 2 actuators controlled by the same directional control valve, one of them's going to be called 1A1, the other one's going to be called 1A2. Because it's controlled by the same valve. Everybody understand that? Yes or no? Okay. It must be set so that it must be set that you can control the extend speed and retract speed of one of the cylinders. You choose which one. So now we're going to have flow control in both sides, right? You understand? And we're going to do what? Meter in or meter out? Meter out. When you look at the valves, you're going to see it's got the little symbol on the side. So you want to point those arrows away from the cylinder, right, toward the valve, and that's the way you meter out. Draw the circuit on a separate piece of paper. Include a service unit and an e-stop button in your design. And then at the end, it's going to tell you how to staple this. Make a list of the components that will be used in the design circuit. Include the component's name and the FESPO part numbers. Label the symbol on your circuit drawing with the correct name and number. Number the symbols using industry standards. On the back of this page, write a detailed description. Y'all good on those detailed descriptions, right? Of the circuit's operation. Construct the circuit using the correct components. Turn the air supply on. Set the pressure to 50 psi. Confirm the circuit operates. And then once you're sure the circuit does how it operates, then you can make the check off. My check off should be real fast, right? What have I been doing? I come over by reading the operating instructions. And then I do what it says it does and see if the circuit responds the way you say it's going to respond. And so that's what your operation is. I'm not concerned with how the thing is built. I'm not concerned with how the fluid flows. I'm just concerned with the way the circuit's supposed to operate, right? Y'all understand that? Or most of y'all got pretty good at that. Okay, any questions on this?
Do you have an example of how your description actually supposed to be done after this one?
What do you mean?
You know, the way you want to write up, you have an example like on the back.
No, this is something you got. This is something you got to do. You've been working on this on three laps now. Basically, you're telling me how to do what. So if I've got to walk over there. If I've got to walk over there, and you got to tell me something to do, then that's not supposed to happen. And this is what we're talking about. What you're doing is I have no idea how to work it. I'm your boss, right? I sent you off to a school. All right, you understand that? And then the thing, you're sick one day, and I got to go out there and get my system going. Right? Do I need to know how it operates? No, I need to go out there and you need to give me a detailed description on what I need to do to turn the dang thing on, what buttons to press, which direction to push it, and that kind of stuff. That's what I'm looking for. Right? I mean, I could put one out there, but you've already done it. What? So what have I been doing? So you didn't have it right. You didn't have it right. What did I do every time? Told you how to get it right now. Now we're to the point where I shouldn't have to tell you that because we've gone through what? Y'all know what next week is, right? Next week. Midterm. Yeah, next week. I know what after that is, right? We're going to start grading we're going to start grading stricter on what we do. You can't keep, if I employed you and I sent you off and I had to constantly tell you how to do something, constantly tell you how to do the same thing, then what's going to happen? So learning how to follow instructions is very, very, very important. And so when I come over there, I hadn't been fussing at you. I've been trying to say, well, you need to do what? You need to tell me, and y'all are getting really good at it. Some of y'all getting really good at it. I go over there, flip it over. I say, tell me what I need to do. It tells me I need to do what? Check the what? Check the disconnect to make sure it's parallel with the valve. Make sure the e-stop button is out, right? If it's in, I need to do what? Turn it and pull it out. Okay. You need to tell me how to do that, right? You understand that. Verify the pressure is 50 psi. Probably need to put how I need to adjust it. So how do I need to adjust it? If it's not 50, I pull up on the cap, turn it, right? Until the pressure is correct. Okay, what else do I need to do? Make sure the cutoff valve is what? Open, right? And then after that, so that's just getting ready to start. And then when I do it, okay, take the selector switch and do what? Turn it left, it'll extend, right? The cylinder should retract. And that kind of stuff. Does that make sense? Okay? Okay, guys, I'll run these off and put them over there in the stack.